My name is Sabu Francis. I'm an architect and also a software developer. This particular talk I had given at Trivandrum at one conference there. This is titled Measuring What Is Not There. It should be a reasonable introduction to TAD, and you should be able to understand the why and the what of what TAD is, and also the what else is needed to understand the context in which TAD works. So let me start. The caveats here is that I'm going to use a lot of analogies and metaphors. Uh, I'll try my level best to make sure that the analogies are pretty accurate. But if you stretch every analogy, at some point it will break. So I hope you don't get distracted by those breakages. I'll be stating the obvious sometimes, but that's very important because I need to tick off certain logical sequence of very obvious things to lead to a particular conclusion. There are not many pretty photos of buildings in this presentation, and you need to tune yourself to look at the various abstractions, logic, philosophy. So you're not really in a usual architectural presentation here. There are three parts to this presentation. The first part is on the why. Why is it that TAD needs to exist? TAD stands for the architect's desktop, and it uses a different way of modeling which is not really seen in practically any other modeler. The second part is on the what it really does, and the core part of it. I'm not going to show screenshots, but I will show the basic essence of how TAD works. And the third part is on the what else, which is the context around TAD, which is also important for people to know this. So architecture is an amazing subject because there is not a single person who can claim that he is not part of architecture. Now, this is not even a metaphor. Every human being is ensconced inside space somewhere or the other. There is no way you can escape that. So it's not something which you say that no, this I'm not involved in this subject. You are, whether you like it or not. So for 9 months we were in the wombs of our respective mothers, and then we get delivered into the womb which is held by Mother Earth. And this is one really special space. Carl Sagan had this beautiful, the pale blue dot talk which he had given. It's there all over YouTube, and he explains it so nicely. If you take a look at the entire universe, it's one huge, massive. I mean, you can't even know the extents of the universe. And inside that, there is this tiny little blue dot which is holding a little amount of space, and we are all there inside that particular space. And lately, it has become critical that we really protect the lining of this womb of this Mother Earth. So there's only one space, and now this needs to be reflected on by architects because they use the term space usually to mean parts of the space, logical parts of the space, like say a room or a window opening, or a doorway, you know. But the honest truth is that architects don't create space. We only modulate and we interrupt space with some built matter. It's that real space actually can never be created, neither can it be destroyed. So this leads to a very important conclusion that what we now consider as built matter, like these walls which is crumbling in front of you in this particular slide, they were all just space once upon a time. And what architects have done is to consciously take parts of that space and then convert that part into built matter. So you can say every built matter is actually a spatial volume into which matter has been poured inside. This comes to a very important point, and this all architects need to really reflect on. We deal with the rarest of rare raw material. Why do I say this? This particular slide shows the the child workers of Congo region, where they are extracting cobalt, which is used in all our mobile phones and electric vehicles and so on. And it is a very tragic situation there. That's one of the very few places where you can get this particular cobalt, and that has led to a lot of exploitation. In a very similar fashion, you can say that when an architect gets a commission and the client says this is this plot of land and you need to build your architecture on top of that, create some architecture inside that volume of space held by that land, you have no choice. You can't say that, okay, let me, make multiple alternatives and keep it there. It's not possible. That space, once it is occupied, is fully occupied. There is no way you can actually say that, no, 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 that I can give multiple things there. There are multiple sources from which the same space can emerge. It's just not there. So all architects, unfortunately, are subject to a lot of exploitation. And many times when an architect constructs something, that construction actually can be there for years, and if there are some mistakes in that construction, it'll actually last for many years. This is a recent event which happened in Kerala only, where some illegal buildings were demolished. So it took a huge amount of legal proceedings, and there's all kinds of uh, expense were incurred just to recover that space once again. In this particular case, you can see all the greenery and all there. It's really nice place, and you can say that, okay, the spaces come back and now maybe something else could be built over there. But this is a luxury which nobody can afford, if I can call this a luxury. It's actually a tragedy that that building gets made over there and then all the built matter is demolished so that you release the space once again. Now, this almost never really happens. It either will deteriorate over years, it's like a chronic disease, and then it will vanish. Once in a while, a few buildings will be demolished like this to recover the space. So, what does an architect really do? My way of looking at it is that architects really can never create spaces. What they do is that they modulate the opportunities using the interplay of solids and spaces. This is a beautiful scene from the Salk Institute, which Louis Kahn had designed. And as you can see, it's very clearly visible the way he arranged the built matter, and you can actually experience the way he opened out the opportunity of enjoying that particular scenery of the space over there. You can actually almost feel that is what he has really done there. It requires a real master architect to create something of this nature. So this modulation of opportunities using the interplay of spaces and solids is a pretty decent and simple explanation of what architects really do. Like, this is a tragic example in India when Modi invited Trump over, and Trump is now, actually today I think he's there in India now, and they hurriedly created these walls and they painted all this. So they have removed the opportunity. Whoever who designed this wall has removed the opportunity of seeing all the dirt and filth which lies inside that particular city, on the way where Modi is invited Trump, and they are going across that city. So here the opportunity of viewing something has been removed. And this example, which is bad, but this is also in one sense has modulated the space over there. Now somebody will say that to say architecture is just a simple way of modulating opportunities which are to be promoted and opportunities which are to be demoted. That makes it very mechanical, very clinical. Where are the emotions there? Why is architecture such a great art also? And where does that come from? So, to understand that, architecture, of course, is extremely nuanced and there are lots of emotions involved in it. And that emotions comes out when the architect is successful in understanding what do you mean by the word opportunity. Because it's not the same set of opportunity which is given to all the users over there. There are multiple users there, multiple age groups over there, and each person himself or herself will be playing multiple roles there. Each role will have its own set of opportunities which you need to promote and demote. So as an example, I'll give you this scenario which I'd witnessed somewhere. So I saw this father who was taking his son along, and they were obviously in a hurry. The dad was in a hurry, and he was like on a half trot almost, and the son, he was holding his son's hand and literally dragging him along. The son was really walking really far. I mean, almost running actually. And I was witnessing the whole scene. They were about to enter a ramp, and the ramp was nicely sloping, a beautifully designed. It had one railing, and the top of the railing, the handrail, was had a nice smooth covering, but the parallel to that handrail were a set of iron members, which was actually sticking out into the out of the ramp and parallel lines, and some of them, those lines were actually in height of that particular child over there. So I was dreading that in that hurry whether the child will walk into the into one of those members over there, which is parallel to the main handrail on top. Luckily, nothing happened. I could have imagined that a little bit here and there, and that child's shoulder may have got hit, or the eye may have got hit, which is even more worse. Now, the father is oblivious of this because he was in a hurry and he was dragging the child along. So, what I'm trying to paint here is that the architect had created that design of that ramp and that handrail and the elements below the handrail and everything, but the opportunities for the father is way different from the opportunities for the child. And that's the nature of architecture, that whenever an architect designs something, you are actually need to understand the various types of opportunities which simultaneously needs to be handled, whether be it for a father or a son or a mother or the child or all combinations thereof. And that's why that real poetry and the real nuanced way of making something very evocative comes out. So poetry is definitely there in architecture. I don't want to discount that. I was just trying to say that it still doesn't mean that architecture is not something which is what you say, uh, uh, very complex in one sense, the sense that like you are playing with opportunities which are promoted and demoted, and the way you play with that opportunities is to interplay with the spaces and the solids there. Now this is actually understood from this example. Sorry, it's understood from this very nice poetry verse from Tao Te Ching, which says 30 holes share the wheels up. It's the center hole that makes it useful. Shape clay into a vessel. It's the space within that makes it useful. Cut doors and windows for a room. It's the holes that make it useful. Therefore, profit comes from what is there, and usefulness from what is not there. So, this particular verse very clearly highlights the logic of what you mean by something which is designed and built. What do you mean by man-made? When man-made objects are made, you are not just doing something profitable with the built material which is there, but you are also worried about the usefulness of the things which you do not put the built material in. So, in short, it's the interplay of spaces and solids which gives the interplay of opportunities promoted and demoted. And that's the very important, you can say, conclusion in this first part of this particular talk. So we have various types of traversals. When an architect is opening up opportunities, he actually opens up openings. As you can see, the child is able to see something through that wall. If that particular opening was there, he will not be able to do that. So traversals, sorry, of various types can be seen. Like you can actually move from one space to the other through a doorway, for example. You can see something where you are static, but your sight is moving from one place to the other place. Or you can have olfactory senses which is getting triggered, so you'll see the here, I mean, you get the smells of things from somewhere. You can have auditory traversals where you can hear the sounds of some place. And I mean, there are a million different types of opportunities which the architect has to assess. At the smaller scale also, there are going to be opportunities. For example, if there is a jali, you have to think about the architect has to think about the opportunity of getting small amounts of breeze through those, push through those jolly holes, uh, and induce a Venturi effect which reduces the temperature inside the room, and you can, control the privacy of people who are sitting under this side of the jali to see what's happening there. So there's a whole lot of assessments of opportunities which are to be promoted and demoted, which we need to do. Now the problem now is that architecture really, when it is built, does not have any alternative. You can't stand there with a clicker, a remote control, and then say, like how you change a TV channel and say, okay, I don't like this, I want another channel there. You can't do that. The building is up there. You can't stand in front of the building with some magical control and say, okay, I don't like to experience this particular building. I will now change this building and I will use the new alternative because I don't like this alternative which is there in front of me. That's the nature of architectural experience. So that means after the architect has designed and has interplayed with opportunities and promoted some, demoted some, and then use spaces and solids to do all that, once all that exercise is over, it finally results in a building out there. And that is the reality. At that synthesis of that particular instance, there is nothing much anybody can do. So there is really no point in criticizing that building. And Albert Einstein famously said this: no problem can be solved from the same level of consciousness that created it. Now, this is needs to be understood very finely. When we look at some act of creation, that is one thing. But if you try to understand what was the problem which was being solved, you cannot look at the thing which is created and then walk backwards from it to know what was the way by which that particular problem got solved. So empirical reality cannot be modeled by retracing the steps. So if this vase has got broken, you cannot, say that, okay, this is a bad design which has happened there. Now you metaphorically cannot pick up those shards of that glass, of that vase, and then put it all back together to understand what was the problem which was being solved, because the problem which was being solved, the effect of that is already disappeared. You don't know that, so you cannot do this. For a year in 2016-17, I was at this beautiful place at Ooty. It's really lovely. It's about 10 kilometers away from the city. The environment is really pretty, and inside one old disused quarry, somebody had made a higgledy-piggledy collection of buildings, and there's this college over there, this institution over there. And I was at that institution. If you look at the design, you can make out it was made in a hurry. The architecture is really bad, and everything over there really needs a lot of improvement. It is not even designed climatically. It's really cold over there, but it is not doesn't respond very well to the cold. A whole lot of problems in that particular place. But this particular college has been existing for, I think, about 15 years now. So there has been a fair amount of batches which has come out there, and I'm sure there are some people, some students have actually fallen in love when they were there for 5 years in this particular campus, and they must have got married also. Now, if you ask them what is the architecture over there, it'll be very difficult for them to bring out any bad points, because one of the loveliest memories which they had is actually finding their soulmate over there. So what happens is, when you try to criticize the built environment, it is intersected with so many other things about your life that you just do not have any value by criticizing it. In fact, you can't take that built environment and figure out what were the opportunities which were to be promoted and demoted, and did that architect do a better job, because you don't have the alternative in front of it. You can only compare between alternatives, and since there is only one reality which you are staring at, there is no way by which you can actually deduce like what really went wrong. So what I'm arriving at here is that, having said that this is how architecture evolves and finally results in some built form, and that gets built over there, uh, the way we proceed while designing is one thing, but what it results in is another thing. And the unfortunate situation is that we make drawings which actually represents the construction side of the story. So now let me digress this discussion a little bit, this talk a little bit, and talk about the Ooty bison since we are still stuck in the images of Ooty. Now the Ooty bison is an amazing animal. It's almost half the size of an elephant. It's about 2 tons, and they are very gentle nocturnal creatures, and they have this amazing connection to a prehistoric animal called the auroch, the wild auroch or the wild bull it's sometimes called. And this wild auroch had a significant influence on the way humankind shaped up. So you would see the wild auroch's horns and the face as cave carved, drawings on cave walls. So they were the first very primitive pictograph which was used as a written language. And this actually, the initial cave drawings were very clearly indicative of that particular animal. But over time, it became more stylized. And then, if you see this from left to right, if you read this, it actually, that bull's head finally turned around, and you get what is now we use as the Roman letter A. So the horns of the bull is actually pointing down. Now, what I'm pointing out here is that human beings actually work really well when they are not able to use associations which comes from the real world. So when this, in the olden days, when people started writing things and describing what their problems were and everything, and they used pictograms which were analogies, visual analogies of the world they were in, the things which influenced them, and they used that as a method to really talk about their problems and their solutions. Those days maybe it made sense, but later on, many years later, when we are looking at those cave drawings and all that and trying to understand the script, you just do not understand it anymore because those analogies are no longer relevant. And what were those cultural and temporal associations which people had while representing that? They are all gone. It's only now when that particular written script became bereft of all the visual analogies that we can actually stand and peacefully look at a piece of writing, and we don't have to bring in images of the real world around us to really talk about that language. Imagine if something like this was to happen in Kerala where it's full of coconut trees. Maybe the initial script would have coconut trees as one of the script which is there in this particular land. I mean, we've not discovered it. But if that was the case, we would have been half the time when you're reading some script, we would have got, influenced by the visual connections to the real world around. Now, this has got a very big point which I'm making here on that when architecture is being designed and then we have carefully figured out all the interplay of solids and spaces, and then finally we came up with the building itself, and the building is out there, but unfortunately the drawings which we use for making that building is technically just a pictogram. So we are at a pictogram level as far as the written script for those buildings are concerned. We, those drawings are actually directly related to whatever we are building, and this is actually corrupting the interpretation of what that particular design is, because in fact it's not even talking about the design, it is talking mainly about the built matter which is there. So the conclusion of all these points, logically I'm trying to tell, is the language of designing of architecture is one glorious mess of all kinds of things being discussed between all kinds of people. But that does not necessarily mean that's the same language which is used for constructing the building. When a building is getting constructed, finally, when after all the debates and discussion during design is settled, and all the problems and the opportunities which have to be promoted and demoted, all those discussions are over. Finally, we need to actually construct that particular building, and what we do is that we make drawings for that. Now those drawings actually has got a construction bias. It is, if there's a technical term called poche stands for the dark marks which we leave on a drawing, which represents the built matter which is there. And these poches are used by people like this mason who's constructing a wall over there. He's been asked to leave a window. Now he doesn't know why that window opening is required there. He need not know either. He is interested in making the wall. He's been employed to make the wall, and the dimension of that wall is very much needed. Fortunately, these built matter comes nicely shrink wrapped in a geometry. You will see the meshes very easily, even in computer aided drafting software, 3D software. You will see that all the built matter can be nicely, put a mesh around it, and that mesh is accessible, so we can actually count that, and we get reassured that we know how much material is going into that particular building, and so on and so forth. But if you remember that first verse which I was telling you about, the Buddhist sloka, the Buddhist verse, where they say the usefulness of what is not there. But here also you can see there are several openings in these drawings where it is going to be useful. Having that hole is very much useful for those particular products which is there. But really speaking, you really can't measure that directly. The software is not representing that. The software has put mesh on the one which is built, and this has been an approach which started with Brunelleschi, and he made this really phenomenal task of putting a dome on top of the half completed Florence cathedral, and he did such a beautiful job of that. He was one of the first guys who knew how to make a linear perspective. He was quite well versed with drawings and everything. So this was the first successful use of drawings which helped in shaping that particular dome over there. And that dome was constructed using some remarkable engineering to almost 20 stories up in the air. And then he did not use any scaffolding for that. He used some other inventions of his, some of it which is actually lost in time. Nobody really can recreate what he has done. There's a beautiful book about all that, where which lovingly tells what all things Brunelleschi had done to create that dome. But the fact remains that he was also talking about what is built and not what is not there, the spaces. Eventually we got the space, we got to enjoy the usage of that space, but the sad reality is that that space was not represented. Why is it that all this has happened? Why is it that when we architects are talking about buildings, we tend to be lopsided in our representation? We are supposed to represent both what is built and what is not built, and it is really tragic that we think that we are very creative and all that, and this is a hard problem to solve, and maybe it can't be solved. But we should quietly think about it. Musicians got the same problem as what architects have. Musicians also have something as a universal space, which is universal silence. So think of silence as one thing which you really cannot create. It is always existing, and it's always all encompassing. And in that silence comes all the notes which that musician has to play, and the notes are the things which gets interrupts that silence. But when you look at that musical notation, you find both the silence, which is a space, and the notes, which is equivalent to the built matter, both are actually represented over there. And it is tragic that we are not really debating this particular issue. We are sitting down and saying, you know what, you have a complex problem, so let's reduce it into its basic components. And reductionism is a philosophy which kind of comes in and helps you out in some situations. But if you stretch it too much, it can be pretty absurd, like this particular invention of the mechanical duck, which was constructed by Jacques de Vaucanson. And if you look at that, if I got the pronunciation right, that is. And this duck, he has reduced it into its components of a duck, and he thinks that this is actually the duck. But that's not the duck. We all know that it's not the duck. The problem with reductionism is that you cannot divide a particular complex thing into its individual components and figure out the interrelationship between them. And that's the end of it, because we don't know where to cut up the boundaries of this. And we may be excluding something which is actually very important. Of course, it's lots of things are important, and a duck obviously is not just this. There's a second problem which we do, which is also stemming from reductionism, is known as the fallacy of extrapolation. We tend, when I tell about TAD and the way I go about representing buildings, many people say, what man, like we already have drawings and all that. Let's start with drawings. We can then later on figure out what to do with the spaces. This all come over time, we'll come to know that. We can look at a drawing and we'll come to know what the spaces are. Yeah, but when you look at a drawing and you realize some spaces, you have to realize you have been trained to interpret those spaces. But the next guy, next architect who is collaborating with you, he's trained in a slightly different way. He's recognizing the spaces in some other ways, and there's going to be a lot of confusion. So you can't just extrapolate and say, "Hey, we have to start somewhere, no, and then we have to go to the next step." That is not the right way to do it. It's called the fallacy of extrapolation. There's a third problem, which is a philosophical problem of modeling, which is known as the problem of infinite regress. It's like being inside a barber shop and seeing an infinite reflections inside you, inside the mirror, because there's a mirror in front of you and there's mirror behind you. Now, what I meant by this is that many time modeling is assuming that, like, okay, here is the real world outside, and then let's take part of the real world like a painter and bring it into your canvas over there and insert that. Somebody peeps over your shoulder and say, oh, you forgot to represent that part. So you go back to the nature, pick up that part, put it back into the painting, and this goes to and fro, to and fro so much regressively that it never really ends. Then later on you realize that what you thought was a reality, or what your friends also thought was a reality, just like in a barber shop, it was actually a mirror there also, and that mirror itself was reflecting some other reality which you have not yet got sensitized to. So it's a whole lot of mess over there if you just try to do a one-to-one connection between what you see in architecture and then what you have to represent. This was very nicely explained by this beautiful painting called the Treachery of Images, which basically in that painting says, Ceci n'est pas une pipe. I don't know, peep or pipe, I don't know how you pronounce it in French. So basically the translation of that, it says, this is not a pipe, which is obviously, it's an image of a pipe. But in this particular slide, I am actually showing an image of the pipe, because there's a lady over there who's looking at that image of the pipe. I mean, this is just a kind of a pun on top of that particular treachery of images. So it's a treachery of the treachery of images. And this is what actually is a sum and substance of my criticism of drawings. Drawings can never explain the reality. It is anyway lopsided. I could have gotten into Jacques Derrida and his understanding of logocentrism and what he calls as difference, but that will make this talk really lengthy. My last paper was in IIS in 2018 January, where I had explained the linguistic aspects of my software. Anyway, this again, Albert Einstein comes to rescue. He says that not everything that counts can be counted, and not everything that can be counted counts. What he was referring to can be also applied to our drawings. We think that all the built matter, we can obviously measure the geometry and we can figure out the volume, we can find out the cost, all that. That can be counted. But there are many things which we still need to count. We need to measure what was not there, the spaces we need to measure, but that is not represented in that particular drawings, and therefore we think that that's not really important. But of course it is important. Both are important. This comes to another very hairy topic, which is a separate discussion by itself, that if we are not clear about how we are starting our representation of our design problem as architects, then surely there will be a sequence of events which will lead to what the chaos theorists people, they say it's called the sensitive dependence on initial condition, and the entire process of coming out with the design will veer off to somewhere else which you don't know where it will actually finally end up in. So you may think that you started pretty accurately with all the things in place, eventually it can go really awry. So finally the conclusion of the first part is that the reality of architectural problem has got a lot of points regarding opportunities which have to be promoted and demoted. For that we have to know what type of spaces and solids need to be interplayed with, and we need to really worry about a lot of different kind of opportunities for different kinds of people, different age group, different culture for the design problem which is at hand. And while doing that, if all we did was to use drawings to do that, we are going around with one hand tied behind our back, a hand which should have explained spaces but doesn't explain spaces. We generally talk only about the built matter, and this creates a lot of chaos and there would actually be a chaotic understanding of how that particular design evolves. Finally, we make only the drawings which that building is talking about. Trying to criticize from the drawing back or from the constructed building back will not work out at all. And this was the reasoning why we need to change the representation system which architects use, which is why the second part will start, which I'll now explain how TAD actually represents any built form. It can be from a smallest of nails all the way to a large city. Everything can be represented using the representation system seen inside TAD. As a starting imagery, you can keep the idea that a volume of space can be looked upon as if you have filled it with some magic fluid inside, and it's like jello. That means you can reshape it the way you want it. So having kept this image in your mind, now I will show you how every building can be, during the design process, can be represented as a set of spaces one inside the other, something like Russian dolls. So here it goes. The outermost volume of that one building. Now let's say there's one building with just one room inside. So the overall volume of that room is called the envelope, which you can see here. And you see this equation, just this particular equation will be seen in all the slides. You will see this equation coming up and explaining what that building is. So here is the outermost envelope, which is the total volume of that particular room. Then inside that you carve out and scoop out a spatial volume which we call an atom, because you don't further subdivide it further. So this is the second type of volume of space which is existing inside inside any building. The third type of volume would be what is known as a connector, and that is connects between the faces of an envelope or other space, not just envelopes, and any other space. So it actually does the connection part, and those are the three different types of spaces which exist. Actually, I'm not the first guy to talk about this. It was talked about poetically by Rob Creer, another architect. And I think there were a few other architects who did understand the present, the tangibility of spaces, but it never got a mathematical formulation. I'm probably the first guy who actually is formulating as a piece of mathematics. So if you see, the built matter is actually known as the leftover, is a Boolean subtraction between the envelope, and from that you subtract all the sum total of atoms and connectors. Now if you use this, you'll find that it doesn't just represent this one particular building which has got just one room with one doorway in it, but it can actually represent any building, any built matter, whether it is from a city to a building to, in fact it can go all the way down into a furniture, which I will just come to. So if you see inside, suppose inside that room there was an artifact which is there. And what is that artifact? That artifact itself, in this case, is a collection of envelopes and atoms over there in this particular design of the table. But you could have other holes in it, and we could have a drawer in that, and the drawer itself could be a set of atoms, envelopes and connectors. So what I am trying to say here is that every building, every design built of the built environment can be broken down into a collection of atoms, envelopes and connectors, one inside the other, and you can get a very succinct fractal representation system, which is what is so shown in this slide. What it says is that it's called the SFA classification system because it stands for Savo Francis and Associates. That's the office where I was when this particular classification system got discovered. And if you look at it and if you study it intensely, you can pause it and study this particular slide. You'll find that it actually covers entire of all the possible starting points for architecture. You could talk about the solids, you could talk about the spaces. The spaces itself is a collection of atoms and connectors. You subtract that in the right sequence, you'll get something known as leftovers. But some of that leftover could be artifact, and there's something else called a link node, which I will reserve for later to explain what that is. That's like columns and beams and electrical wirings and all that. So all this is what actually gets captured inside TAD. So here is a quote which was way back in 2001, pretty prescient quote, which spoke about how fractal systems are coming to simplify a lot of parts of our life. Today, without fractal modeling systems, you cannot have beautiful landscapes seen in movies and and illustrations, like movies like Life of Pi, the water which is model, or Jurassic Park, the skin of the various dinosaurs. All those things are at the core are have to be represented using fractals. Weather prediction happens because of fractals, and therefore I feel that if architecture, which is a very intricate and very involved subject, which is where the architect has to use a different set of process in their mind, they also need to be done using fractals, which is what TAD does. Now let's come to the third part. What else needs to be counted? What is the situation in which we this kind of practice, which now uses, instead of using drawings as a way to communicate amongst all the collaborators and stakeholders of an ongoing design, we use TAD and use this particular SFA fractal classification system to put together all the elements of a building and then assess it. The advantage is that each part of that particular element, every part of it is available for querying. There's an internal scripting system in TAD which allows you to actually go around representing each part which is meaningful and do a calculation on that based on various criteria which that architect and the collaborators may need. All this is happening. What is the other context? What's the social context in which we are sitting right now? And the social context is like this, that it started with one question which I had asked a famous architect. I was working for him, Hafiz contractor. We were only 8 architects when I was with Hafiz. And he's really a very talented architect, extremely knowledgeable architect. And I was disappointed that he was not producing quality which he could have produced. So I asked him this question: why is it that you're making, I mean, you're not obviously using all your knowledge for your building, you're making such mediocre stuff. So he had a very brutal business like answer. He said that nobody's pushing me. If nobody's pushing me, why should I sit down and do anything more than that? That is actually, if you reflect on it and you grit your teeth and understand it very unemotionally, it's quite true, right? If I'm running a 400-meter race, my job to win the race is not to be 100 meters in front of the one behind me. I just have to be a few millimeters or even nanometers, if they can measure that, behind in front of the guy behind me, right? So you don't win by yards and kilometers before you will be regarded as a winner. So similarly, an architect is designing something and he is making an impact on the world. And if you really want to produce certain things, this architect is telling that all I have to do is to do it slightly something better than what anybody beneath me is doing. So what is my problem? I won't do anything more than that. So this got me thinking, and I came up with this theory which is kind of iffy, but it needs to be understood, and maybe sociologists would be able to reflect on it and comment on it. Economists should be able to comment on it. My hypothesis is that society is a set of vertical stack, a stack of writers, a stack of musicians, a stack of poets, a stack of architects, a stack of doctors. All these intellectuals are arranged together inside a tube. I call it the puttu tube. Puttu is a Malayali dish, Kerala dish, which people make by stuffing coconut inside. Rice powder interspersed with coconut, and it's all steamed up. There's some pressure generated inside that particular tube, and once it is cooked, somebody pushes one bamboo from beneath, and out comes this delicious dish ready for you to eat. So my theory is that all these vertical stacks of intellectuals get cooked inside their own vertical cylinder, but the people who will be noticed in that would be the one who's arranged at the right at the top of the cylinder, and they come to the top of the cylinder not necessarily by talent, maybe because of contacts, because of nepotism, because of some other factors, and also talent also, of course. Now they are over there right on top, and there are a next layer of people who are beneath, who are pushing the guys on top. The one beneath that is pushing the guys on top, so a whole lot of vertical pushes are going on. But if this particular vertical push is not properly consistent and really strong, you will get a very poor dish. The whole thing will just fall apart. A badly made put will actually just disintegrate. It's not very tasty to eat. And same thing happens. In fact, this really happened in a small country called Nauru, where there was this vertical stack of intellects who were not really, that particular stack was not putting enough pressure inside, and the top guys in that particular country, they did some really bad moves, and the way this turned out was really tragic. This particular island is a small 21 square kilometer island near Australia, and it had a lot of bird shit, guano, where the birds, the seabirds used to settle on this island and then shit over there for centuries, and this had created a lot of stack of phosphates. It was actually bird shit which turned into phosphates. And some people saw the opportunity of mining that phosphate after the World War, and then selling that for a good profit. There was a period when that particular island was the most prosperous island. In fact, it was the richest country in the entire world, and they made such bad decisions. They could not understand how to really conserve all this, and the entire landscape got exploited, and all the phosphate was sold off. There was nothing which is now remaining. The country has become one of the poorest, and that's because that vertical stack of social pressure was not properly built, and the whole society really has crumbled. It is now, Australia uses it as a prison to keep all illegal immigrants, and it's such a sad story that in a few years the whole thing collapsed. So what I'm talking about here is that if that society has to come up with really good quality work, any society, they have to really start understanding how to apply that pressure, and the real quality work should start right at the bottom of that stack, from fresh architects, from simple architects, architects who really do not have any great presence, because they are right at the bottom of the stack, so no way can they be pushed out right from the top. And there are a couple of Nobel Prize winners who came to tell how to apply that pressure. Unfortunately, economics is not taught in our syllabus in architecture in India. Neither is sociology properly taught. So this is totally oblivious. So people who come out in practice, they have their homegrown theory of how they should cooperate with their other people over there. Now, John Nash came up with this observation on non-zero sum games. And now non-zero sum games is actually quite a good model for competition among the peer group in, say, a bunch of architects competing for some project. Now what happens is, zero sum games are games like chess and football, where there is a clear outcome that you are either a winner and somebody else is a loser. So you give -1 mark to the loser, winner gets 1 mark, and therefore the sum is zero. Or you give zero to both the people if it's a draw, so 0 plus 0 is still 0. So such games are known as zero sum games. And more hairy games, which is more reflective of how people compete in the real world, like in a traffic jam, as you can see here, that is known as a non-zero sum game. And a non-zero sum game, people thought that there is no way by which you can optimally get the best out of that non-zero sum game. So game theories never really addressed that. But John Nash came up with the what is known as the Nash Equilibrium, and he said that there are situations where you could actually get some kind of equilibrium even in non-zero sum games, and that requires you, in this particular case, in that particular traffic jam, you are supposed to step out of that particular car you are in and help the other people you are otherwise competing with, and cooperatively together you can achieve a much better equilibrium and much faster equilibrium. So this is one lesson which we do not know when young architects come out, and fresh small little architects who don't have much influence in society. They are lower down in that put to stack. In that put to stack, they are inconsequential is what they think, and they end up not really cooperating with each other, and therefore they don't end up really putting that pressure inside that stack. The second thing is also, second point about sociology is also about economics, and this is also about another Nobel Prize winner. His name is George Akerlof, and there were some other colleagues. They worked on what is known as information asymmetry. And he said that in economics, there is something called supply and demand, and there is an assumption that both the suppliers and the people who are demanding that thing, they're all privy to the same kind of information. But the real world is messier. The real world, many times the seller of some information, is holding back some information, is not revealing everything to the buyer. And this creates what is known as information asymmetry. And when there is information asymmetry, the chances of information slipping down and becoming bad, and the quality becoming bad, as you can see in that explanation here, he started analyzing used car market, like where people go and buy a car which is pre-owned or a used car, and the salesman is giving some glib talk, and the buyer says that he's too glib, maybe he's hiding something, and probably he is hiding something. And when that buyer feels that, maybe the seller is skimping on something and he's not really telling me that, so they will lower their willingness to pay. When that happens, the prices go down. When the prices go down, the seller is further reducing the quality because he wants the same amount of profits, and this whole thing deteriorates when the whole market starts descending down, and you get really bad products in that particular market. Now, this happens even in architecture. We are all sitting down and cribbing about how we know something which the lay people do not know. So we are pretending that we have a lot of understanding of architecture, when the reality is that everybody is involved in architecture. And that's what I started this presentation with. And we actually, many people, what they do is, like, they'll go and try to handle the third point, which is prices will decline. So all architects will sometimes meet together and say, let us get our organization to enforce a minimum fees, and this is what everybody should charge, and you should not do that. But that's the wrong place where you should start. You should actually start with the step one, where the seller and the buyer should be talking about the product which is emerging in that office, that is the architectural design, and keep it transparent, keep the design knowledge transparent, educate your clients, tell them that this is what is happening. The whole community of architects should really explain what to the lay people, what is being done there. Unless there is transparency, unless the information asymmetry is removed, you will face this particular Nobel Prize winner's prediction, and you are actually sitting down and reducing the chance of applying pressure inside that put to stack. And my contribution to this is that let us have a way of talking about the design process. And for once now in the design process, it is possible to talk about both the built matter and the spaces together. So let's try to use that instead of just using drawings. And thereby, when architects are designing their projects, they are actually in a position not to speak in silos, or put that knowledge only in silos, and hide things from others. Instead, like, suppose an architect, a small bunch of architects designing one residential colony, and another set of small architects are designing another residential colony. Now these two architects can actually sit down and make a meaningful comparison, which they can actually tell the world that this is how my project is coming, and that is their project is coming. Or even within their own office, if they want to select what is the right design which they have to give to their end user, they can put up a bunch of alternatives and then put that in front of the clients. The clients will know the kind of effort which has gone, and know that they got the best possible deal for the design which has evolved. And for all that, you need to have a representation system which is quite all encompassing, not just talking about the built matter, but also about the spaces. So that's the final slide of my presentation. That's what TAD is all about. It's a measurement system. It's a modeling system. Sorry, not measurement system, and a modeling system which has got a built-in scripting language. And instead of looking at computer languages as something which is exclusive domain of only computer scientists and all that, it is a tool. Finally, it's a mathematical tool which we all have to be engaged with, and so that we generate a very rich, nuanced, meaningful set of representations when the design is going on, instead of hovering only at the construction stage and talk only from the construction point of view. Thank you so much.